Good afternoon. Welcome to today's lesson on section 9.3, which is about graphing and writing equations of circles. As I promised, it should be a pretty short lesson and also pretty easy. So in this lesson, we'll discuss circles, which all of you should be familiar with. However, we'll take a somewhat deeper look at what a circle truly represents. So just like we did with parabolas, we'll start with the Euclidean definition of a circle. A circle is a set of all points that are equidistant from a fixed point. Which makes sense, because if you have a fixed point and you draw a circle, that wasn't a very good circle. But if you picked any point on the circle and connected it to a fixed point, and then pick another point on the circle and then connect it to the same fixed point, those distances will always be the same. So it's a set of all points equidistant from a fixed point. The fixed point is what we call the center, and the distance between any point on the circle and the center is called the radius. So these are things you should already know. What I'm actually going to do is let's do the derivation of the equation of a circle. So okay, again, that wasn't a great circle, but say that's your center, which we'll call it 0, 0. Remember, that's your fixed point. Let's call that x comma y. That's a random point on the circle. So this is supposed to be a constant length. So if you use distance formula, which we've talked about earlier in this unit, and I said distance formula kind of forms the basis for the rest of this unit here. If you use distance formula, d will equal x minus 0 squared plus y minus 0 squared. So I'm finding this between these 2 points. Or r, because the distance we can call r, equals the square root of x squared plus y squared. If you square both sides, very simple, r squared equals x squared plus y squared. And that's the equation of a circle. Of course, with the center at 0, 0. You're used to seeing the center outside of 0, 0, maybe like at 1, 2, or negative 2, negative 5. And we call the center h and k. But we'll talk about that when we get to 9.6 after ski week. For now, let's keep everything at 0, 0. Just keep it simple. Alright? Just a few quick examples and the video will be over. So here you have to graph the circle. So to rewrite in standard form, that right there is standard form. So if I rewrite as x squared plus y squared equals 36, the center, obviously at 0, 0. The radius, hopefully you identify as 6, because remember that's r squared. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Dot here, dot here, dot here, dot here. and there's a circle. So pretty simple. Here's another one. We'll use green for the freshmen. So point lies at 2, -5. Center's at the origin. You want to write an equation of a circle. So it probably will look something like that. And of course that's your radius. So the radius will simply be the distance between 2, -5 and 0, 0. So it should wind up becoming root 29. So equation should be x squared plus y squared equals 29 because you have to square the radius. Again, pretty simple. Last one. We'll try yellow, but it's going to be a little tricky. Maybe I'll use a highlighter for this one. Write the equation on line that's tangent to the circle x squared plus y squared equals 13. So if I try graphing the circle, it always helps to graph it first, just so you can visualize it. Try graphing to visualize. Because remember, r is going to equal root 13, which is roughly between 3 and 4. And you have the point 3, -2, which will probably be right here. Remember, tangent has to touch it at just one point. Another thing that's important to know is that the radius and tangent line are always going to be perpendicular. That's back from geometry last year. So you want to write the equation on line, y equals mx plus b. X comma y we know is -3 comma 2. I hate when I do that. Okay. Let's try this again. Can't rewind, but that's alright. -3 comma 2. There we go. So -3 comma 2. Okay. Again, the radius will be perpendicular to the tangent line. So in this case, m for the radius, if I work that out, remember that's -3 comma 2 and 0, 0, that'll be 2 minus 0 over -3 minus 0, which is -2/3. So for the tangent line, it's going to be the opposite reciprocal. So it'll be 3/2. So if we work it out, y is going to equal 3/2 x plus b. Let's use -3 and 2 for x and y. Solve for b, and you should get 13/2. So your equation would be y equals 3/2 x plus 13/2 for the tangent line. So that should cover everything for today's lesson on section 9.3. Let me make sure I actually got that problem right, because I don't like the fact I made a mistake earlier. Cool, I got it right. Alright, so we're all set. So just make sure you took notes on this. I'll check them tomorrow, and we'll do some practice on this as well as more practice on 9.2. Alright, have a great rest of the day. Bye.